Assalamualaikum warahmatullahi wabarakatuh, and a very good day to you. So for today we will go into chapter 1, which is Introduction to Mechanical Engineering Design. There are 3 topics in chapter 1, which is the first one is Introduction, second the engineering design process, and last is planning for design activities. The lesson outcome for this topic is first is to define the concept in mechanical engineering design. Second is to describe the process available in mechanical engineering activities. And third, manage planning of the design activities. So what is engineering design? Engineering design is the process of devising a system, component or process to meet a desired needs. The main characteristic for the engineering design, usually it involves a decision making process, and sometimes it is an iterative process. The meaning of iterative process is mean that the design process usually happen in many times, which is repetitive, in which the basic science, mathematics, engineering science are applied to convert resource optimally to meet the stated objective. And among the fundamental elements of the design process are the establishment of objective and criteria, synthesis, analysis, construction, testing, and evaluation of the solution. As you can see here, this is the engineering design process flow chart, which is it is started with the problem, define the problem, and then after we define the problem, we will go into gathering information related to that problem, and after that when we have the problem have been defined, and then we have all the resources related information related to that problem, we will go into concept generation, and after concept generation we will go into evaluation of concept to choose which concept is the best to bring the concept into the final design. And then after evaluation of concept, we will go into the product architecture, configuration design, and parametric design, which is these 3 steps is also known as the embodiment design. And lastly, after we have finished with the embodiment design, the 3 process, the final step is to make the detailed design. So our focus in this subject, which is Mechanical Engineering Design 1, MET 531, MET 531, there is 4 items that we will done, which is the first one is problem identification and definition, which is one to define what is the real problem. And then second, we go to search the information of that problem, which is we will do into a comprehensive information. And then third, after that we will go into concept generation, which is to diverse ideas to get a numbers of solution, and then from that a number of solution we will go into concept selection, which is we want to choose the most optimal concept which can solve that problem, focusing on balancing feasibility, functionality, and other criteria. So this is the 4 stage that we will cover in this subject MET 531, which is mechanical engineering design. And then the remaining step, which is product architecture, configuration design, parametric design, and detail design, will be covered in the next semester subject, which is mechanical engineering design 2, MET 533. Before we can start with the design process, there are the things that we need to understand first and to get ready, which is the most important activity. We call it as planning for design activities. So in this topic, there is three activities that we need to go through. The first one is to forming the team, because effective engineering design usually require the collaboration of engineers with different skill and expertise. And then after we have done with forming the team, we need to have some of the problem solving tool in order to define the problem and to get the idea what is really happening to that problem. And then the third one is to plan and scheduling. So it is important to develop a plan and schedule for the design project, which is to ensure that your project can complete on time and within the budget or within the resources that you have. The reason why we need to form a group of people, which is the team, is one, to get the benefits of teamwork, which is teamwork we can collaborate and foster creativity, because we know that everyone is not the same, and then everyone has its own opinion about something. So when we have a group of people with different opinion, we can brainstorm an idea how to solve that problem. And then of course a diverse expertise strengthen the design solution. So this is the reason why the design process usually happen in a group activities. And then some of the effective team formation, which is usually when you have a resource of a number of individuals, we can consider for team composition. That means that the team, if you have when you have a number of individuals with different skill and knowledge, usually we can select and put that individual into their role to form the team. So second is to building cohesive and productive team. So these two will affect whether the team is effective or not effective. Composition of team members, and then ability to build cohesive and productive teams. Now let us go into on the team leader, characteristics of team leadership type. So usually we have three types of leader. The first one is the traditional leader, passive leader, and facilitative leader. So into the first types of leader, which is the traditional leader. The characteristics of the traditional leader usually is directive and controlling. No question, just do it. And then he have the power of the decision making authority. The leader usually hard to trust the person under his command, and usually ignores input from the team members and autocratic. So this is the traditional leader types. Let's go into the next types of leader, which is passive leader. Usually hands off, means that don't want to give some cooperation to the project. Too much freedom means that he or she did not guide their members. So team members usually go out from the scope of the project. And then lack of guidance and direction. So this is the same thing as too much freedom. And then extreme empowerment means that the power that have in the team members usually is more powerful than the leader. Uninvolved and a figurehead. So this is the types of passive leader. Next, we go into the facilitative leader. So what is the characteristics of the facilitative leader? He or she usually creates open environment. Open environment means that team members can give contribution, team members can give idea, team members can give comment, and team members can give critics. So this is the facilitated leader. And then encourage suggestion, provide guidance, embrace creativity, consider all ideas, maintain focus, which is the goal and criteria. So of course, from all of these three types of leader, I want you to learn to those leader who have been chosen by your team members. Please try to learn to be a facilitative leader. Not only on this group project, when you try to learn to become the facilitative leader, the skill under these types of facilitative leader will become your soft skill. So you can put your skill as a leader in your resume. So this is the benefits of this subject, means that you, beside of gaining knowledge about the mechanical engineering design, you also can develop your soft skill, and then this soft skill you can put in your resume, and because you have developed it, so it is yours to prove, to show to the people that you have this criteria, you have this characteristic. So what is the team leader's responsibilities? Among the team leader's responsibility is to conduct and lead the meetings. So in meeting usually happen to know which or at where is your progress in the design project, and also if you have problem, so you can discuss in the meeting and to find solution to that problem, so that you can progress with your project activities. And then the team leaders should manage a day-to-day activities, means that he need to control the schedule and to make sure the things or the activities or the tasks meet with the schedule planning. So this is also some way track progress towards goal. And the team leaders also required to develop the team skill, and then become the voice to speak with the sponsor if you got sponsor, and then he or she need to remove the progress barrier. So anything that stop the project from progressing, the team leader need to remove that problem. And last, when the teams have conflict, the team leader will need to solve that problem, so that the team can work as a team. The rules of thumb for forming design project team, you can see here. The first is to have the design team should have diverse skill sets, which is to ensure team members possess complementary skill that align with the project needs, such as technical creativity, problem solving skill, able to use SolidWorks, such as, and so on. And then second is to have the clear roles, means that everyone in the team should have a distinct roles and responsibility for each team member, just to prevent overlap and confusing job scope. Third is to make a collaborative capability, which is to select individuals who can effectively collaborate, communicate, and share ideas to foster the design team project. And then availability, which is to ensure that team members have the time and resources to commit with the project demands. And then the fifth is the experience, which is the team members should have relevant experience and expertise that can make the project progress. Adaptability, one of the characteristic, which is individual can adapt to changes and to solve unexpected challenge or problem, and he or she can adjust to make sure that the project able to progress. And last is the person, the team members should have passion and motivation to make contribution for the project success. So this is the rule of thumb for forming the design team project. But for your scenario, for your situation, you have only 3 person in the group, so means that you can try to learn how to become to meet with this set of criteria. So this will become your skill, and of course you can put in your resume later. Now we go into the problem solving tool. In the engineering design, usually there is 3 types of problem solving tool that you need to master first. First is the problem definition tool. Second is the cause finding tool, and third is the solution finding and implementation. So let's go to the first tool, which is under the problem definition. Usually in problem definition, among the tools that we can use to identify the problem is brainstorming, and then affinity diagram and Pareto chart. So this is the tool that we can use to define the problem. Second is the cause finding. Among the tools that we can use is gathering data, such as interview, focus group, and survey. So all of these three tools we can use just to get the data. And then after you have the data, we can analyze the data by using tools of check sheet, histogram, flowchart, and Pareto chart. And then after you have analyzed the data, we can do for the root cause, finding the root cause, the real root cause. So the tool that we can use to find the root cause, we can use cause and effect diagram, YY diagram, and interrelationship diagram. Okay. And last, under the solution finding and implementation, so solution finding, we have three tools: brainstorming, how diagram, and concept selection. And to implement the solution, we can use force field analysis and written implementation plan. So not all of these tools under problem definition, let's say you use all, maybe we can use one or two. Same goes with the cause finding under gathering data, whether you can choose interview, focus group, or survey, or you can choose 2 or 3 or all of these tools. So which tool that you will use? It depends on your discussion amongst your team members. So now let us see some of the tools used. First is the cause and effect diagram. So what is the cause and effect diagram? Cause and effect diagram is a powerful tool to identify the real cause of the problem. This cause and effect diagram, also known as the fishbone diagram or Ishikawa diagram. So this is a very well-known method or tool used to identify a problem. In industry, usually they will use this fishbone diagram, just to know what is the real problem related to that issue. So how to create it? Start with the horizontal line, which is the spine of the fish. So this is our horizontal line. It same as the spine of the fish. And then draw diagonal lines, which is acting as a bone extended from the spine. So this is our diagonal line. Major diagonal line, it will become the bone of the fish. And third, label each bone with a potential cause. So this is the spine, this is the bone, and then for each bone we will label what is the potential cause of that problem. For example, here the problem is bad shoulder joint, and then what's the problem that may contribute to this problem. So the potential cause we put into at the end of this bone, which is diagonal line here, such as the weighting stand off too high, insufficient shoulder pace, tombstoning, coil joint. So all of this is the main potential of why bad shoulder joint happen. And after that, you can add sub course branching of the main course. So all of that end of this title for the diagonal line, which is the bond. So this is the main potential cost, and you can add sub costs related to that main potential cost, such as as you can see on the derivative under the line of diagonal line, we can add the sub costs which contribute to the wetting problem, such as insufficient flux, poor board cleaning, for example, and then corroded pad, which is poor board pre-cleaning, and then for example, under the coil joint cost. So the sub costs that contribute to coil joint may be vibration while solidifying and then cooling too slow. So this is the main potential cost, and then below it is the sub cost that may contribute to this main cost here. And then after you have managed put all the detail, the spine, the line diagonal here, which is the bond, and then the main potential cost, and then the sub costs that lead to this main potential cost, you can analyze. So for your project, you will use this cause and effect diagram to identify what is the real problem related to that product. Okay, you will use this tool. Another tool that we can use to identify what is the real cause of that problem is the YY diagram. So what is the YY diagram? YY diagram is the problem solving method to dig deep into the root cause of an issue. So how to create the YY diagram is to start with the problem statement. So here is your problem statement. Let's say lack of understanding about research. So this is for the example of the problem statement. And then how to use this YY method diagram. So you need to ask the problem, why lack of understanding about research happen? So you can answer that question by putting the answer on the next. So ask why to identify the immediate cause. So why lack of understanding about research? So this is the answer. Potential answer, such as faculty don't communicate to student about research, no cost for student on research, and lack of incentive for faculty to involve student. Okay, so this is the potential cause, and this potential cause later we will ask. Let's say why faculty don't communicate to student about research. So you can answer that. Maybe the potential answer is strong emphasis of research with grad student, and then crowded syllabus leave little time for faculty to discuss research. So this is the potential problem that lead to faculty don't communicate to student about research. And then you can, in order to dig deeper about this problem, you can ask again. So why, let's say why crowded syllabus leave little time for faculty to discuss research? So you need to think the answer, and then let's say you have the answer. So you just put at the back, which is information explosion, lack of active learning in classroom. So this information, this answer usually will answer the the reason why crowded syllabus leave little time for faculty to discuss. For example, so you can apply this method to determine what is the potential cost of your issue that you want to solve. Yeah. Okay. So now we go into the interrelationship diagram. So what is the interrelationship diagram? Interrelationship diagram is a tool to analyze complex relationship and interaction between the potential factor that may cause to that problem. So let's say we go look into this example here. So this example is related to bed soldering process joint. So how to correct it? First we will list all the factors or variables relevant to that problem. So we have a table here. On the left side, we will list all the potential causes that may affect to the belt soldering joint, so such as poor design of component leads or error in fabrication of leads, and then improper bolt cleaning, solder fast you use beyond its shelf life, expired maybe, and then incorrect selection of paste, solder, binder, flux measure is not well chosen, and then poor operation or maintenance or real flow soldering machine, and then design or maintenance of stencil is poor maybe. So after you have managed to list all the possible cause to that problem, such as the bed soldering joint, you will so this potential cause here you will symbolize with a number here with a okay, such as A represent the poor design component leads, B represent improper bulk cleaning, and after you have determined the variable or the potential problem cause, so you will draw a raw arrow to represent connection between factors, such as you can see here, D, which is incorrect selection of phase or soldering, will result into E, let's say E, yeah, because arrow comes from D towards E, so from D, which is incorrect selection of phase, will result in poor operation or maintenance soldering machine, and then from D also will result into F. So what is F? Design or maintenance of stencil, and then from also D will result in B, such as here for example, which is improper bolt cleaning, and then also from D will result in C. So C is solder paste used beyond its shelf life. So this is the reason incorrect selection of phase that may brings to cause. And then so after you finish with the drawing the arrow, you will count for each of this list of variable or potential cause. You will count how much the arrow goes into this variable list of potential cause, and how much errors comes from this list of variable. For example, if we go see the point of D here, so D have 1, 2, 3, 4 arrows out, so we stated 4, but here is 3, maybe have a problem here. And then from D we see there is no arrow in, so 0. And then let's say we look into point C. So point C we have 1 arrow out, So C, one arrow out, and then for C there is, sorry, I want two arrow out. So two arrow out, and then one arrow in, and then for F there is no arrow out. F, there is no arrow out, but there is two arrow in. So you need to look into this number of arrow in and number of arrow out. For B, there is two arrow in, means that this is the reason, this is the effect, and then there is no potential cause here, arrows out. But when you look into the D, there is no arrow in, mean that this is not the effect, but this is the reason why the problem happened, because arrows out means that it means the effect of this point D will affect into point E, point B, and point C. So usually we will count the which variable or cause that have the highest amount of error out. For example, this point D here, it will become the root cause. And then we have the how diagram. So how diagram is the problem solving tool to explore and clarify the detailed step or action needed to achieve the goal. So how diagram, one of the tools to find solution. Okay, one of the tools to find solution. So same with the YY diagram. So YY diagram before we used to find the real cause, but how diagram we will use to find the solution, how to solve that problem. So let's say start with a clear goal or objective. So let's say this is your objective, to avoid incorrect selection of solder phase, because we previously we have say example that avoid incorrect selection of solder phase is the reason why solder joint is bad solder joint. So we want to avoid incorrect selection of solder pairs. This is the objective that we want to do. So we will ask how to avoid incorrect selection of solder pairs, and then among the answer that given is to check unnecessary shed life, keep viscosity within limits, match plug with cleaning equipment, ensure plug activation and melt range are compatible. So this is all the possible solution that may result in avoid incorrect selection of solder pairs. So if you want to dig more deeper about that solution, we can ask how to check on necessary shelf life. So we use the how diagram here. So we ask how to check on necessary shelf life. So we can get the answer maybe to determine the expected rate of usage. And then let's say to under the solution of ensure flux activation and melt range are compatible. So how to ensure this? We can use manufacturer's data sheet. Yeah. Alright, so how diagram. We will ask how to get solution. Previously for the YY diagram, we use YY diagram to find the real potential problem related to that problem. Now we go into the planning and scheduling. So what is planning? Planning in engineering design is identifying the key project activities and ordering this activity into its correct sequence for execution. And for scheduling, scheduling is allocating allocating the planned activities within a specific time frame of the calendar. Work breakdown structure, also known as a WBS, is used as a project management tool to break a project into its manageable segment. The purpose of WBS to ensure that comprehensive understanding of the project, of the scope of project, scope of work. And then the key element is to list all the task outcome rather than the plan action. And then the advantage of WBS to know the outcome so that we can predict accurately at the project outset. So here this is the example of WBS for development of small appliance. So under the major activities such as product specification, concept generation, embodiment design, detail design, production, all of these major activity, we will break down the structure. For example, under the product specification, the work that include in this product specification, for example, is to identify customer need, and then conduct benchmarking and establish a product design specification PDS. So these three activities will fulfill the product specification. And then let's say we go into the detailed design also here. For example, under the detailed design process, it has four activities in detailed design, such as integration, check of subsystem, tolerance and analysis, finish detailed drawing and build lots of material, prototype, test result, correct product deficiencies. So this is how we break down the structure, yeah? And then for each activities, we will set how much time is needed for this activity, such as under the identify customer need. We, for example, here it's set as a for for hours maybe, and then for conduct benchmarking it's at 2. Okay, so this is WBS. So for your project, you need to make this WBS so that you can understand what is the required activity needed to fulfill the main task here. Okay, so you need to do this also. So from the WBS previously, so you can create your own Gantt chart. So what is a Gantt chart? Gantt chart is a visual project management tool that used to plan, schedule and track tasks and their timelines. So how to create the Gantt chart? First, to identify project tasks and list them. So this is the project task. One way to look into more clearly which task to be done, you can do the WBS work breakdown structure, and then you can take all the tasks and put here. After you identify the project task, determine the task duration and dependencies. Okay, so for each task they will have the timeline. For example, remove internal here, given that this task will need 3 weeks. And then under the construct support, so construct support will only can be done if remove internal activities have been complete. So construct support, the timeline for construct support, it start on week 4 after the remove internal is finished on week 3. So construct support start from the week 4 until the week 7. And then after that, install YouTube. Activities will start on week 8. So this is deficiencies. So each of these tasks will require the task before to be done completely before this task can be done. Sometimes the task can be done parallelly without need uh, without need uh, the task before to be completed, such as here install internal wiring can be done at the end of this install internal wiring here, yeah, on parallel, and then install heaters and install internal wiring also can be done parallel. So this is example of the Gantt chart for prototyping testing on heat exchanger. So you will do your own Gantt chart based on the mechanical engineering design activities here. And then the duration of your project should include for this semester should include until the concept selection activities. Okay, so this Gantt chart we will do in group activities after you comes to the campus, after you celebrate with your raya puasa. Okay guys, so that's all for chapter 1. Thank you for watching and listening. I hope you have learned something, which all of this such as the tool, the forming team, and then tool for defining the problem and to make the solution, and then Gantt chart is an important factor to be learned and to be used in mechanical engineering design.